This presentation, titled Risk Assessment Teach 1 Assignment, was prepared as part of the HAP 725 course on Statistical Process Improvement, taught by Professor Alemi at George Mason University, Department of Health Administration and Policy. Taylor Galownia is a student in Health Informatics field graduating in 2020. For this presentation, I will be walking through question 2 of the Week 3 assignment, where we are asked to calculate the likelihood ratios for all 4 ICD-9 codes present in the dataset. Our goal is to complete the table shown above. In the context of this problem, a likelihood ratio is the likelihood that a specific event, in this case an above average hospital stay, will occur in a patient with a target disease compared to the likelihood that the same event will occur in a patient without the target disease. The target diseases are myocardial infarction, coronary heart failure, diabetes, and alcohol use. Before calculating likelihood ratios, we must binarize the diagnosis data. Shown above is a SQL statement that binarizes the occurrence of the disease as 1 and the absence as 0. These results are saved into a table named index. The next step is to calculate the weighted average length of stay for each diagnosis. We use the SQL statement above to do so. We calculate the weighted average instead of simply an average because the number of patients varies for each case. Now that we have calculated and saved the weighted averages, we can begin calculating likelihood ratios. The next step shows how to calculate the likelihood ratio for myocardial infarction. The top paragraph of SQL code shows how to assign patients with an average length of stay above weighted average as 1 and a below weighted average stay as 0. The resulting variables are has MI and long stay, has MI and short stay, does not have MI and long stay, and does not have MI and short stay. In the bottom paragraph of SQL code, we see how to actually calculate the likelihood ratio using the declared variables average length 1, long, and short. The formula is essentially taking the prevalence of myocardial infarction patients with a long stay and dividing that by the prevalence of total patients with a long stay. Then taking that number and dividing it by the prevalence of myocardial infarction patients with a short stay divided by the prevalence of total patients with a short stay. Shown above is the SQL output for the MI likelihood ratio, which is 3.47. The next step shows how to calculate the likelihood ratio for coronary heart failure. This code is essentially the same as the code seen before for calculating the likelihood ratio of MI. However, this time we substitute anywhere that there was the variable MI from the index table created in the first step with the variable CHF to get the likelihood ratio for coronary heart failure. Shown above is the SQL output for the CHF likelihood ratio. This likelihood ratio is about 5.5. The next step shows how to calculate the likelihood ratio for diabetes. Like the myocardial infarction and coronary heart failure example, we simply exchange the variable for DM, or before that was MI, and keep the backbone of the code the same. Or I'm sorry, we take out the coronary heart failure variable or the myocardial infraction variable and substitute in the DM, which is for diabetes. So this will be giving us the likelihood ratio for diabetes. And shown here is the SQL output for the diabetes likelihood ratio, which is about 1.6. The next step shows how to calculate the likelihood ratio for alcohol use. If this looks familiar, it's because it is. Like mentioned before, we are using the same backbone code and exchanging DM this time for AA, which is alcohol use, to get the likelihood ratio for alcohol use. Shown above is the SQL output for the alcohol use likelihood ratio, which comes out to be 2.6. Finally, we consolidate the results of likelihood ratios for each of the 4 diseases into one table in Excel. This view allows us to easily see which diagnoses have a higher or lower associated risk for an above average hospital stay. Looking at this table, we can conclude that patients with coronary heart failure have the highest risk of a longer hospital stay, while patients with diabetes have the lowest risk of a longer hospital stay out of these 4 ICD-9 codes. In conclusion, we could use the following statement to apply the generated likelihood ratios into the context of the situation. For example, we would say patients with myocardial infarction are 3.47 times more likely to have a longer hospital stay than patients without myocardial infarction. This concludes my Teach 1 presentation on likelihood ratios and risk assessment. I hope you were able to learn something. Thank you.